Okay, so topic 2 in Unit 12 is about trend lines. So in topic 1, we talked about how often scatter plots do have a pattern to them, and we call it a correlation or an association. So topic 2 is about looking at that pattern or correlation and actually creating a mathematical function, whether that be a line, like we're going to focus on today, trend line, or a curve of best fit, which is often what we use for quadratics and exponentials. So let's first take this situation about Anna. She, after 5 minutes, was running at 10 miles per hour. At 10 minutes, she was running 8 miles per hour. At 15, she was running 5 miles per hour, and at 20 minutes, she was running 4 miles per hour. So it says complete the table below, create a scatter plot that pairs both the speed and the minutes she's been running. So at 5 minutes, she was at 10, 10 minutes, she was at 8, 2 minutes at 5, 20 minutes, she was at 4. Okay, so question B says, is this an example of causation? So is the time that she is running causing her speed to change? Well, yes, the longer she runs, the more her speed's going to go down. She's getting tired. Okay, how is the data related? Positively, negatively, or not at all? Well, negative, right? These points are generally going down, so this is a negative correlation. Then letter D, describe the association between the number of minutes that Anna runs and her speed. So we're going to say as the minutes increase, because we read from left to right, her speed decreases. Okay, now letter E, here's the kicker. It says if we wanted to know what Anna's speed would be after 25 minutes of running, how would we do it? So here's 25 minutes right here on our graph. We don't have a data point that tells us her speed, but we can kind of make an estimation based off of the other points that we have. So most people, if I said, okay, just make a guess, they might tell me like 2 miles per hour, or they might say 3, somewhere in that range, right? If I said, is 7 a good estimation? The answer would be no, right? That doesn't follow the pattern. Even if I said 4, is that a good estimation? The answer is probably no, because your eyes are visually making a trend line, okay? I'm going to do the best I can to draw a straight line here, but it's probably not going to be very straight. So the points that she has generally are going in a line that follows that blue line I just drew, right? So for 25 minutes, we can expect her speed to be somewhere in this range, okay? Maybe it would be right here at 2, right? Might be a little bit above, a little bit below, because again, these points over here are not in a perfect line. These points have not followed a perfect linear function, but they are generally trending in a straight line in a negative direction. So to answer the question, how would we figure out the 25 minutes? We would create a trend line, which again, you typically just do naturally just with your eyes, but there is a mathematical way of doing so. So a trend line is simply a linear function used to make predictions I'm needing a what's the word, preposition. Make predictions about, that's the word I'm looking for, a scatter plot. Okay, it follows the general pattern of a graph, but we use it mostly to make predictions. It's the only reason we need it. So number 2 says graph the following lines on the graph at the right and provide, or which line provides the best fit with the points that have been plotted. So letter A says y equals 2x plus 1. Throwing it back here, this is y equals mx plus b slope-intercept form. So I'm going to start with my y-intercept of 1, pretend that's on the 1, and my slope is 2. So up 2 over 1, up 2 over 1. I'm drawing this line. Okay. Does that look like it follows the general pattern of the points on this graph? I would say no, not so much. It's way too steep, right? So let's try the next one, 1/2 x minus 2. So here's the minus 2. I'm going to go up 1 over 2 for my slope. Draw this line. Does this line best fit that data? Well, I will say it's got a better slope in the sense that it's flatter, but it's too low, right? This would be better if we just shifted it up, right, to match all those points that are already up there. So I'm thinking B is out. Okay, 3/4 x plus 2. So let's try this one. Y-intercept of 2, 3/4 is our slope, so up 3 over 4. there. Draw this line. That line does align with the coordinates on our grid. So of the choices that we have, letter C makes the most sense. It goes along with our points the best, okay? Letter D, we could investigate here, but really before I even graph it, I can tell something's wrong. The y-intercept of 8 is probably way too high up there, and this negative 1/4, that means our points are going to trend down. We don't want a negative correlation here. We want a positive correlation so our points are going up. So C would be the most appropriate trend line for this graph. So number 3 says the scatter plot below represents the number of guppies that carry bought each month for 6 months. What type of correlation is the relationship between the number of guppies and the number of months? So again, our options are positive, negative, or none. Those points over there are going up, so positive. Letter B says draw a line of best fit. Again, this is just going to follow the general pattern of the points, just the general trend. That's why it's called a trend line. So it's not going to be perfect. So I'm just going to draw a line that generally goes through the points. You'll notice that I skipped a couple. I didn't hit this one, I didn't hit this one. It's impossible to do so without playing connect the dots, right? So that's okay that I missed a couple. You're just wanting to hit as many as possible, and if you can't hit them all, go through the middle of them. It's best, actually, really, I probably could have done a better job to have a couple points above the line and a couple points below. So this probably could have been shifted up a little bit, but it'll work. So if Carrie continued this pattern of buying guppies, predict how many she bought during the 8th month. Here's our 8th month right here. If I read up my graph, it intersects with the trend line that I have drawn right here. Well, looking across, that is somewhere in between 25 and 30 guppies, right? So we could say maybe approximately 27 guppies, but we don't really know, okay? I would say as a teacher, I would accept an answer probably anywhere between 25 and honestly 35. If your line was a little bit steeper, that'd be probably a-okay with me. If you gave an answer like 10, that would not work. That's way too low, right? If you gave an answer like 500, that'd be way too high. Now letter D says what is the approximate equation of the line you just drew? So again, approximate is underlined because this is an approximate line, right? So if I'm shooting for slope-intercept form, y equals mx plus b, and I look at so I'm going to start with the y-intercept, which for this problem looks like it's just a little bit south of the origin there. So maybe, I don't know, -1. We'll just estimate here. My slope is going to be a little bit harder to find because I need 2 perfect points to find the slope, but I probably don't have any. If you don't, you just want to use the best points that you can. I would say I could use this. That actually looks pretty good as a perfect point. And even though this one isn't exactly at that 2, 5 coordinate, I'm going to pretend like it is and use that one. Okay, same with when you look at your own lines. If you have something that's close to being a perfect point, use it. For example, this one wouldn't be that bad either. I would say don't go for something like that. That's a little bit too far off from being a perfect point. But just find 2 things that are as close as you can get and use those to calculate your slope. So I'm going to use, like I said, this one and this one. So my rise is 5, 10, 15, 20. My run is 1, 2, 3, 4, 5. So my slope in this case would be 4. So 4x minus 1 would be my equation. Okay, and again, that's just approximate. It is not perfect. It is not a big deal. If I tried to test it out with this line, I'm sure these points would be a little bit off. But it's also probably not as bad as you think. For example, if I try to plug in a 6, I should get a little bit over 20. If I plug in a 6 here, 4 times 6 minus 1, that gives me 23. That's not that far off, right? So this is an okay line, an okay equation to use for our line. Alrighty, so here we go again. We have a graph where Mr. Smith wants to see if there's a correlation between his student's test score in math and his test score in science. So we're going to start just by putting all these points on the graph. I'm going to go ahead and pause my video while I do that. Feel free to pause this video while I do that so that we can both get back together once we've graphed our points. Alrighty, so there's the data on the graph. Part B says, does the scatter plot show a positive, negative association, and is this an example of causation? Well, even though it's slight, this is a positive correlation or positive association because those points are going up. Again, it's pretty flat. This is a low slope, but it is positive. Causation, does the math score cause the science score to be a certain number? The answer is no. This is not causation. If you make a 35 in your math class, for example, that does not carry over into your science class and cause your score to be something. Those are two completely separate classes. They're not going to cause one to be the other. They might be related. If you struggle in math, it might cause you to struggle in science, but they're not causing one another to be a certain thing. So now letter C, draw and use a trend line to predict the math score corresponding to a science score of 50. So again, when you draw a trend line, just do the best you can to go through the middle of the points. As you can tell, obviously, these blue points are not in a perfect line, so you're just going to have to do the best you can. One misconception is that people think the trend line has to go through the origin. That is not the case, especially if the data doesn't look like it would go through the origin. So for this graph, for example, ooh, my board kind of wiggles right there. So pretend that's a straight line, but I would say that is a good trend line for this data. So this y-intercept in this case is close to like 35. It did not end up being at the origin at all, okay? So they want to approximate a, let's see, science score of 50. So I'm going to go over here. Science was on the y-axis. I'm going to read across, and it hits right here. That would be something like a maybe 28 in math, okay? We don't know the exact score, and again, it will vary a little bit. Letter D, use your trend line to predict the science score corresponding to a math score of 65. So again, I'm going to go over here to the math score of 65. I'm going to read it up. Hit right here, read across. That's about a 65. Again, these are just approximations. We can't know exactly. There is no formula that tells you what your score will be in one class if you get something in another class. So these are just guesses. Then it says again, what is the approximate equation? So y equals mx plus b. I've already mentioned that my y-intercept is probably something close to 35. So I've got y equals something x plus 35. But then I still need my slope to calculate, or to get the rest of my equation. So I need two perfect-ish points. Again, doing the best I can here. So I like this one right here. Again, it's not perfect, but it's pretty good. And I'm going to use, let's see what else. This one right here. Again, not perfect, but that's what I'm going to use. So my rise is 10, 20, 35. And my run is 10, 20, 30, 40, 50, 60, 70. Okay, so rise over run, 35 over 70. That's actually 1/2. Okay, now again, total estimation there. If you're working this out on your own paper, you may actually have a trend line that has a slope of, I don't know, 3/5 or, I don't know, 7/13. Most likely it'll be somewhat close to mine. Like if you actually calculated the decimals, it should be somewhere around, 0.4, 0.5, 0.6. If you end up with like a slope of 12, that's obviously too steep. So there is a way to get this wrong, but it is still an approximation. Okay, so the next thing we're going to do is actually create some data and a trend line based off of an activity where you guess the age of famous celebrities. So because this is a video, it's going to be a little bit different than how we would do it in class. But as I display a picture on the screen, you're going to want to write their name here. Okay, I'll just go ahead and tell you the first one's Ellen DeGeneres. The name doesn't really matter, it's just for you to keep track of people. You're going to want to guess, and I'll give you a little bit of time to guess. So you'll just guess, I think they are 100 or whatever. And then I'll show you their actual age, and so you'll type, or you'll write their actual age right next to it. So she's 11, just not the case. Okay, so I'm just going to click through these. Again, you'll write down their name, your guess, and their age. If you're getting nervous about me clicking too fast, you can always pause. It's a video that makes it nice and easy to pause things. So here we go. Person number one, like I said, is Ellen DeGeneres. So there's her name, maybe. There we go. And she is 60. Next person. If you didn't know, that is Shawn Mendes. And he is 19. If you're just waiting for you to display the age, you really do have to guess in order for this to work. So make sure you're guessing an age before you reveal the actual age. This is LeBron James, and he is 33. This is Dr. Axelson, our principal. and he's 43. That is not Michael Scott, his official name, his real name, Steve Carell. And he is 55. Our handsome man would be Justin Timberlake, and he is 37. This one might be kind of hard. That is Blue Ivy. That's Beyonce's daughter. I needed somebody who was younger in here. Guess how old she is? She's 6. That is our Cowboy quarterback, Dak Prescott. And he is 24. This sweet little lady is Betty White. And she is 96. She's doing real well for 96. That guy you may recognize, that is Solomon Thomas, Coach Thomas's son. And he is 22. That is Miss Oprah Winfrey. And she is 64. That is President George W. Bush, Texas native. And he is 71. Last but not least, we got this Stranger Things co-star, Gatton Matarazzo. I'm not sure if I'm saying that correctly. Sorry, bud. And he is 15. All right, so take the data you just collected by guessing the ages and writing out actual ages, and create a scatter plot of your data on the graph that has been provided. I'm going to go ahead and pause my video and put some points up there just so that we can talk about this. But go ahead and create a graph using the guess age as the x value and the actual age as the y value. Okay, so you should end up with some points on your graph. Looks something like mine, a little bit different. I just kind of threw random points up there. So let's talk about number 2. What would it look like if you guessed the exact age of every celebrity? If your guess was exactly the same as their actual age, right? What would those points look like? Think about a table or some coordinates here. If they were really 7 and you're a perfect guesser, well, your guess would be 7. If they were 20 and you guessed 20, well, it'd be 20. So if I think about putting those on the graph, for example, go down here to 4. If your guess was 4 and they were 4, you'd have a point on 4, 4. If your guess was 8 and they were 8, you'd have a point on 8, 8. All the way up the graph like this, right? Your line would go from corner to corner perfectly through the graph. I got a little wiggly there because I was trying to hit all the coordinates there. But that would be a perfect guess line, okay? Some of y'all might recognize that as something else. That would be the linear parent function because all of your x's would be the same as your y's, right? In other words, y equals x, okay? So number 4, how can you tell how accurate of a guesser you are? Well, how close you are to that perfect guess line. If your points are all over the place, you're probably not a very good guesser. But if they're all right along this line, then you're doing pretty good. You're just a little bit over, a little bit under, okay? So, how close to y equals x your points are, okay? That's just a fun little activity to practice and to think about, too, what some of the trend lines might be or could be or should be in certain situations. Okay, I think that's it. Yes, it is. So let me know if y'all have any questions, and I'd be happy to